Hi, this is in continuation to our previous video lecture where we were going through the SN2 reactions, right? And we have seen that SN2 reactions depends on the concentration of your substrate and the reagent, right? And these reactions are single step reactions, right? And the order of reactions would be 2, since it depends on the 2 reactants, the substrate and the reagent, so its order is 2, right? And this is mainly undergone by primary halides. Right? Now in this, what will happen is, in these reactions will undergo through a transition state, right? Like we have studied that previously, that SN1 reactions will go through an intermediate, which is a carbocation, right? This is a single step reaction where you have a transition state, right? In that transition state, the leaving nucleophile, right, the weak nucleophile and the attacking nucleophile, which is a reagent, would be bonded to the same carbon atom, right? Now the transition state is short-lived. One of the nucleophile would be replaced, right, which is a weak nucleophile, and that would be replaced by your strong nucleophile, right? So we'll be looking into its stereochemistry also. So it is your carbon, right, Cl plus OH, right? In the transition state, you have a leaving weak nucleophile and you have an OH minus strong nucleophile, right, bonded to the same carbon atom. This is your transition state. Now, since OH is a strong nucleophile, the oxygen, right, has a strong electronegativity, right? So this strong nucleophile will attract the shared pair of electron towards itself, right, thereby forming bond, right, with the carbon atom, and this will leave, right? This Cl will leave, the bond with Cl will break. Why? Because OH is a strong nucleophile, right? It will attract the shared pair of electron, or it will attract the bond pair towards itself, right, thereby forming a bond with carbon atom, and this will lose that electron pair and will be replaced by OH, right? And it will result into alcohol, right? Now let's quickly look into the stereochemistry of this reaction. Now let's see how the attacking when we say stereochemistry, how the attacking nucleophile would attack in space. Stereo means space, right? So how these reactions, how these attacks are taking place in 3 dimensions, right? Now just look at one thing, that this is negatively charged, right, and this is also negatively charged, right? So if we look at the reaction in space, right, this is your Cl, right, when OH will approach, right? Now since this is also a nucleophile which is a negatively charged, right, when it will try to approach from here, this would get repelled, this would get repelled, right? So this OH ion will approach this carbon atom from the side far away from this nucleophile, already present nucleophile, right? So this OH will approach from the back side, right? This back side is far away from the Cl, the already present nucleophile, right? So this is its important stereochemistry, right? So when the product will form, if the already present nucleophile is here, right, then in the product the nucleophile would be in the opposite direction, right? For example, if it is here, if I want to draw it correctly, if this is not the correct one, if based on stereochemistry I'll draw it, the product would be this, right? The nucleophile would be present in direction opposite to this already present nucleophile in the product, right? Since if you look at this, this is an inversion of configuration, right? First, in the reactant, the nucleophile is here, right? Now in the product, the nucleophile is in the rear side, right? If this is your molecule, right, suppose this is your molecule, Cl is here in the reactant, right? Now since this OH is negatively charged, if it will try to approach this Cl from here, it will get repelled, right? So this Cl will approach from here, from the rear side, right, like this, from the rear side. In the product, this nucleophile would be present here, right? So it has resulted into inversion of configuration. Earlier the nucleophile was here, in the product nucleophile is here. So this is your inversion of configuration. We call it as your Walden inversion, right? After this, the product would be look like this. First the Cl is here, then in the product the nucleophile would be here. It would be here, right? So this is your inversion of configuration, which we call as Walden inversion. We call this as Walden inversion. This is important, right? This is your Walden inversion, right? Just remember how inversion and why inversion of configuration is taking place, because you already have a nucleophile which is negatively charged, and if this attacking reagent, which is a nucleophilic reagent, will try to approach this primary halide from this direction, it will get repelled. So it will attack this primary halide from the direction far away from this Cl, which is the rear side, right? Like I said, it's this side, not this side. Here Cl is already present, so it will attack from the rear side. So in the product, the nucleophile would be in the opposite direction, right, in the rear side, right? So that is why so this product has resulted into inversion of configuration if you compare it with the product, the reactant, right? Product has a nucleophile in the opposite direction, in the rear side. So this is known as, since it has resulted into inversion of configuration, we call it as Walden inversion, right? I hope this is clear. So this type of reaction, SN2 reaction, would be shown by these reactions would be shown by your primary halides, and SN1 reactions would be shown by your tertiary halides, right? And in your SN1 reactions, you have the rate of reaction depending on the substrate only, right? Because the ionization of substrate is a slow step reaction, right? And the slow step reaction decides the rate of reaction, right? So here, this is your slowest step reaction, which is the ionization of tertiary halide resulting into carbocation. Now this carbocation, if you look into the stereochemistry, is a planar molecule. It is plane, right? Now the approaching nucleophile can attack this planar molecule from either side, right? If you look at this, this is your carbocation. This nucleophile, right, can attack it from this side, right? If it will attack this carbocation on this side, it will result into this. It will attack from this side, it will result into this, right? So these are enantiomers, since they are mirror images of each other, right? Now this reaction will result into your racemic mixture, but if one of them is more than the other, this is not a racemic mixture, because racemic mixture means your 50% of both, right? So one of them may be more than the other, which is not exactly 50-50. So this is not exactly racemic mixture, right? and this, remember, this is your first order reaction. Rate of reaction depends on substrate only. Now if we compare it with SN2 reaction, 2 means order 2. It depends on the concentration of your substrate as well as reagent, right? Reagent is your nucleophile, stronger nucleophile. And this is a single step reaction where, since this reaction, like, it goes through carbocation, which is an intermediate, your SN2 reaction will go through a transition state, which is a high energy state, where you have carbon atom. In the transition state, the carbon atom is bonded to the attacking nucleophile and the leaving nucleophile. Since this is a strong electrophile, the attacking nucleophile is a strong nucleophile, because basically in substitution reactions, a strong nucleophile will replace a weak nucleophile. So it will attract the bond pair towards itself, thereby forming a bond with carbon atom. Since it has displaced electron pair towards itself, the rupture of its bond, carbon bond with Cl, will break, right? It will result into the product. Now important thing is, if you look into the stereochemistry of this reaction, this approaching nucleophile will attack this molecule, this primary halide molecule, from the opposite side, right, from the far away side. Why? Because this Cl is already negatively charged. What it will do is, it will repel this approaching nucleophile, so it will attack it from the opposite side, resulting into the product that has nucleophile, right, in the opposite direction, right? If you compare it with the reactant, if reactant has nucleophile in this direction, in front direction, the product would be in the rear direction, right? The nucleophile in the product would be in the rear direction, right? Since, like, if Cl is in this direction, then the approaching nucleophile would attack from the rear end, right? So what will happen is, finally, from the front end, weak nucleophile will leave. From the rear end, from the back end, this strong nucleophile will attack and form bond with carbon atom, resulting into inversion of configuration, which we call as Walden inversion, right? So this, one of the main differences, this goes through a transition state, this goes to an intermediate state, right? And this will result into Walden inversion. This will not result into inversion of configuration. This depends on the concentration of substrate and reagent. This depends on the concentration of substrate only, right? Because the ionization of substrate is a slow step reaction. Now this is a single step reaction, this is a two-step reaction, right? And your SN1 reactions, tertiary halides undergo SN1 reaction, and your primary halides undergo SN2 reactions, right? And if you have a secondary halide can undergo SN1 reaction or SN2 reaction, depending on the experimental conditions, right? Remember this. So your primary halide, right, if you have a primary halide, not primary, if you have a secondary halide, right, it can undergo SN1 reaction or SN2 reaction depending on your experimental conditions, right? You can make secondary halide to undergo SN1 or SN2 reaction depending on the experimental conditions, right? I hope this is clear. This is important topic. Thanks.